So, you know how we've been talking about building out that new distributed system? We really need to keep CAP theorem in mind. It's like we want consistency or availability.
I think it depends on the use case. For something like financial transactions, you definitely need strong consistency.
Absolutely. And that's why banks often choose to sacrifice availability for consistency. But let me tell you, trying to explain this to a bunch of non-tech stakeholders is like pulling teeth. Just make everything work all the time, they say.
That must be frustrating, especially when they don't understand that there are trade-offs involved.
You have no idea. And then there's partition tolerance. Everyone wants their data replicated across multiple regions. But what happens when network partitions occur? Suddenly, everyone's concerned about downtime, not understanding that we can't always guarantee both consistency and availability during those times.
Right. So in a scenario with high partition probability, we might lean towards eventual consistency to ensure our service remains available.
Exactly. Imagine a global e-commerce platform where an outage could cost millions every minute. You'd rather have slightly stale data than no data at all. Plus, dealing with eventual consistency means handling conflicts and ensuring eventual convergence, which can get complex.
True, especially when you consider the operational complexity of maintaining eventual consistency versus strong consistency models.
Oh man, don't even get me started on the algorithms needed for eventual consistency. Vector clocks, CAR-ET. It feels like we're solving puzzles just to make sure our system doesn't fall apart under stress.
It does seem like a balancing act between reliability and performance.
Definitely. And sometimes it feels like we're walking a tightrope without a net because any decision we make impacts millions of users globally. Speaking of that tightrope, let's talk about strategies for choosing between consistency, availability, or partition tolerance. Have you ever worked on a project where you had to make that call?
Yeah, I did. It was tough deciding whether to prioritize consistency over availability in a highly critical system.
Exactly. When you're working on something mission critical like healthcare records or financial transactions, consistency is usually king. But it comes at the cost of potentially lower availability during network issues.
That makes sense. In my case, we opted for stronger consistency because any data inconsistency could lead to serious issues down the line.
Good choice. On the flip side, think about social media platforms. They prioritize availability and tolerate some inconsistency because users can deal with slightly outdated information as long as the service is up and running.
Right. So it really depends on the application's requirements and user tolerance for inconsistent data.
Absolutely. And sometimes it's not just about picking one, it's about finding a middle ground. Like using eventual consistency but setting up mechanisms to handle conflicts quickly and efficiently.
That sounds practical. How do you decide which strategy works best for different parts of a system?
Well, it involves analyzing the use cases and understanding the impact of each decision. For example, core functionalities might require strong consistency, while less critical features can afford some level of eventual consistency.
So it's about balancing priorities based on the specific needs of different components within the system.
Precisely. And don't forget to factor in monitoring and alerting systems to catch any anomalies early on. It's crucial for maintaining trust in your architecture amidst all these trade-offs. Speaking of making those trade-offs, let's look at some real-world examples. Systems that prioritize consistency over availability are quite common, especially in industries where data accuracy is paramount.
Yeah, financial systems come to mind. Transactions need to be accurate and consistent every single time.
Exactly. Take banking transactions or stock trading platforms. These systems can't afford to show inconsistent balances or trades. If a network partition occurs, it's better to temporarily lose access than risk showing incorrect information.
That makes sense. What about databases used in healthcare? They also seem like they would prioritize consistency.
Absolutely. Electronic health record systems need to ensure that patient data is always accurate and up to date. Any inconsistency could lead to severe medical errors. So, even if it means sacrificing some availability during outages, the priority is on maintaining strict consistency.
It's interesting how different domains have such varied requirements.
Definitely. Another example is legal document management systems. These need to maintain strict consistency because any discrepancy could have significant legal ramifications.
I see. So these systems focus heavily on ensuring that every piece of data is correct and synchronized across all nodes.
Exactly. And it's not just about the technology, it's also about regulatory compliance and user trust. When you're dealing with sensitive data, people expect nothing less than rock-solid consistency. Speaking of trade-offs, let's shift gears a bit. What about systems that prioritize availability over consistency? There are plenty of real-world examples where this approach makes more sense.
Sure, social media platforms come to mind. Users expect these services to be up and running most of the time, even if it means seeing slightly outdated information.
Absolutely. Think about Twitter or Facebook. Downtime can result in lost engagement and revenue, so they often opt for eventual consistency to ensure high availability.
That's true. E-commerce sites also fall into this category. During peak shopping times, it's crucial that the site remains accessible, even if some data is slightly inconsistent.
Exactly. Amazon is a great example. They prioritize keeping their online store up during events like Black Friday, even if order confirmations might be delayed or show slight discrepancies initially.
It's interesting how these companies manage to balance the need for immediate access with eventual consistency.
Indeed. Another case study is Google Maps. Real-time traffic updates and location data are essential for users, so availability trumps perfect consistency at any given moment.
Right. Users would rather have near real-time data than perfectly synchronized, but occasionally unavailable information.
Precisely. And it's not just about user experience, it's also about business continuity. High availability ensures that operations run smoothly without major interruptions, which is critical for many businesses today.